Um, I'm still putzing with my IMU, and I didn't have any luck really trying to get my IMU to figure out how to turn on that particular protocol that Chip Robotics is using and try to use that cross driver. So I ended up actually buying a Chip Robotics IMU, which I have. And I just back to the house here in Pittsburgh and opened it up, and it is working, which is interesting. Not sure if I share my screen. Close some of this stuff. I mean, if I move it around, I mean, the yaw over here does appear to be matching the same yaw values that I get from the Adafruit device, which is useful. Obviously, I'm just sitting here at the kitchen table, so it's not the most magnetic free zone, but it is working and able to communicate with their software. That's just their Windows. I'm on a Windows machine at the moment, and I tried to load the ROS package on an Ubuntu machine, but was getting some errors. Forgotten the error that I was getting, so that seemed to be more of a ROS issue than a Chip Robotics issue. I think they may have been using Melodic, and I was trying to use Ubuntu 20 on Noetic, so probably some issues with versioning around that. So that's what's going on here. And when I was trying to use my Adafruit deal with connected to my Nano, yeah, you could have told me, you probably already know what problem I was going to run into when I tried to load a ROS driver on my Nano board. I like quickly ran out of memory, and then I didn't have a teensy with me. So I was like, oh, maybe that's a good reason to just publish the results to the serial port and then get it off the serial port. So I burned some time trying to figure out how to just publish or write to the serial port and then pull it off the serial port. And then I was going back and looking at your code that you shared on how to read from the serial port. But that's where I stopped. So anyway, still futzing with the IMU. Oh, never-ending saga. Anyway, that's what's going on with me.
Well, since you started with IMU, I'll tell you about my IMU monkeying around. I was out looking on Amazon and eBay and various other places to find one of the BNO085 modules. And if I go through Amazon, if I want to pay $50 for a module, they can have it to me in like 2 days, but I didn't want to pay that much for it. And everything else wants to take 2 months to ship it because it all apparently has to come from China. And then somewhere on eBay, I was looking and somebody has one for like $21, and I think it's the same company, but got a different name. It's $24. And I said, okay, I clicked on the one and said, give me 2 of the $21 ones. and it pops up and says, "Oh, this is under export restriction,"
Oh,
and
good.
it goes on, and it sounds like it's restricted, so you can't export it from the United States. Yet this is coming from China, and it says all this nonsense and says I have to be licensed to use this or something. And I finally gave up trying to figure out what they're telling me there. I assume it has nothing to do with me since it's coming into the United States, but I decided I just don't want to screw around with it, and I'm just going to continue on with the BNO085 I got right now. But I figured it was going to take 2 months to get here. It still it might show up by the time I need it or want it. So that anyway, I gave up on trying to do that. So back to my BNO055 I've got now. I think either before or since the last meeting, I went through and merged the code for, so Adafruit has libraries for the BNO055, and one of their examples, it says restore calibration or something like that. And it's actually a calibration program. You run it, it calibrates the thing, and it stores the information to the EEPROM in the teensy, or you could use an Arduino or whatever you want. And then so that did seem to be working. So I modified my code that I'm using now so it will read from the EEPROM and calibrate the device. So when you start it up, it says if there's data there, it loads it into the chip. And that seemed to be doing something, and I wasn't sure exactly what it's supposed to be doing. And
Back. You came to your car.
yeah, I'm in my car right now, sitting in the parking lot at the library. So as I was saying, I merged the code so my normal code that will talk to my ROS driver or talk to my fake ROS driver, it reads from the EEPROM, initializes the chip. And as I was going through that code, I got it working. I was stripping it down. And I thought, well, it looks like every time you start it up, it reads the calibration data, puts it out into the chip, and then there's a thing that says, I found the calibration data, I loaded it, but it says, now wiggle it around for the magnetometer to lock on or something like that. So you'd have to wiggle a little bit and it would continue on. And then it says writing back to EEPROM again. So apparently every time you start it, it rewrites the EEPROM. And I ripped that out of there. And first of all, I ripped out the part that just writes it to the EEPROM. And then I said, okay, let's what's the other thing I was going to do? And I thought I didn't want to have to wiggle the thing before I start using it. So I took it out, and it can be really stupid numbers. I don't know why, but apparently you have to wiggle it to make that happen. So I put that back in. So now when I start it up, the thing comes up, my orange light comes on saying it's not going to talk until there's somebody communicating at the other end. And then once it's communicating, you still have to wiggle it a little bit. You just barely have to touch it, and then my little green light comes on. And that's, everybody seems to be happy. And I can sit in the house with it strapped to my robot, start it up, just wiggle the robot back and forth a couple of inches, and it locks and it works. And now when I take it out in the yard, it won't start up and start giving me data. So I don't know if it's not putting the calibration data out, or if I have to be pointed in the correct direction to get it to work. So anyway, my IMU is not talking to me right now, so I got to go back. That'll be one of the next things to fight with, I guess. But I thought at one point I took it out. The first time I took it out, I think it started up. It told me all three of my sensors were fully calibrated, and I'll talk about that with my LED strip in a second here. But it looked like that was working. I drove it around, just around the yard a few times, and then I ran several more tests and came back, looked at it. I wasn't seeing the IMU data showing up, and later I realized I think that's simply in Plot Juggler. I just need to go turn that on. But either I didn't get any data, or I missed the fact that it's there and I need to turn it on. So that's kind of where I'm at with that. I just need to go back and just start playing with that again and get it so it will give me data every time I turn it on. So I did drive it around, and I noticed as I drove around the yard, I started off, all three sensors were fully calibrated, and I drove up ways and turned and headed towards the sidewalk just as it went off the grass onto the sidewalk. So it dropped like an inch or so. So the thing, made some pitch maneuver when it did that. And as it did that, both the magnetometer dropped back one level, and I think the accelerometer calibration dropped back 2 levels as it did that. And as I drove around, I finished out a square, and they stayed at the same calibration level the whole time. And I have no idea. So again, I have no idea why it did that. And if it's going to be doing things like that to you as you're, just in normal operation, I don't think the BNO085 is going to work out. But I have no idea why it's doing this or how it works or anything. So maybe I can fix that by playing with it some more. So, and the fact I've got it, so it's putting out there's actually 4 calibration values. There's another one called system calibration, and I'm not sure what that is, but I want to go back and plot that. That thing's kind of clicking in and out a lot compared to what the other sensor calibration values are doing. So I need to look that up and find out what that's doing too, and if that will do any good to play with it. So the other thing I did, I played with my LED status strip some more, and that's where it's got that 8 addressable LEDs on a strip connected to an Arduino Nano, and I can just send it a string of numbers, and each number tells it which LED to set to what color. So I basically started off, and I just had the 2 values. I had a value from each GPS receiver, so I was taking the GPS/fix message, and in there's a status field, and that status is either 0 or 2. If it's a 2, you've got a full fixed solution, and if it's 0, you don't. And they didn't give me more information than that. So I was originally just displaying those 2 on my status strip, and as I drive around, I can watch it in real time what those 2 are doing, or I can just put my hand over the antenna, and that particular one will drop out. It'll go from green to off, because that's what 0 and 2 are as far as the LEDs. So that was working, but I wanted better indication than that. So I dug through, and it turns out on U-Blocks, they have a nav BVT message that has all kinds of information. And one in there, it's got a thing called flags. And under the flags, it shows if it's the bit position that gives you 128 is a fix, and the bit position that gives you 64 is a float. And either 1 or 2 is essentially a single point fix. And they both come on at the same time, so I don't know which one is which. So I went back into my code that's driving my strip and subscribed to the nav PVT message. And in the callback routine, I said, read up the flags, and they check the bit positions. And I said, if you do in the correct order, I have to say, check the single point first. And if it is, set the color to red. And if the float is active, then I set it to yellow. And if the green is active, it sets it to, or if the fix is active, it sets it to green. So if each one comes up, it just overwrites the color, and then I take the final color and put on the LED. So now I've got an LED for each GPS that tells me more whether I have fixed, float, or single point status showing up. And again, that works in real time. I can put my hand over the antenna, and it'll drop from fixed to a float, or float to a single. So I've got now 2 LEDs for each GPS that's giving me status, and I'll probably throw out that one that's just the either fix or no fix. I'll probably just throw that out completely, because it's this other one gives me better data. And I don't know in the future where you would use that, if you're trying to decide if the GPS is working well enough, where you'd put that in your code. But I can see that now, so as I drive around, I can watch what it's doing. And then on the IMU, I was originally I subscribed to the let's see which one was it on. That's the one where I was reading up all the values from the IMU as a big array, and I just took the appropriate value for the magnetic calibration. I put it on one of the LEDs, and I used whatever color mapping was coming out. So it put out a number like 0 to 3 or 0 to 4 or something, and I just put that right on an LED, so I'd get whatever color that happened to be. And so I went back on that one, and I did a remapping. So the colors that show up on the little RGB LED I put on the interface board that I built, I mapped it to those colors. So now on the status strip, those are the colors follow along the same one. And then while I was at it, I said, take the gyroscope calibration, the accelerometer calibration, and do the same thing. So now across my LED strips on the back, I've got 2 LEDs. Or for the first GPS has the fix LED, and then the flags LED. And then the next one for the second GPS has the fix LED and the flags LED. And then I think I've got a blank one, or no, I finally put in added the system calibration. So I got 4 calibration LEDs coming out of the IMU, and those are now mapped to the colors that I want. So I can just watch that in real time. And that's one of the reasons I know that my IMU is not coming on, because those lights don't come on. And also I can tell by just watching the LED on my IMU board that that's not happening. So again, I got lots more information to watch, and it's just in real time as I walk along behind it. I can see those LEDs, and that all seems to be working out really well. And so again, I just got to go back and play with the IMU now that I've got enough status I can see and figure out why that doesn't start up every time, because I still have to prove whether or not, once it's calibrated, do I get a decent heading? Because if I drive all the way around block, I notice the heading seems to drift somewhat, and it seems like it should be off by a constant offset. If the magnetic is wrong, then when I turn and I'm going 90 degrees, maybe it says I'm going 85 degrees or something, but it shouldn't be drifting up or down as I drive around. That's what it looked like it was doing. So maybe there's something about the accelerometer is influencing the heading, because that's the numbers I'm looking at is all merged data. So it's merging the gyroscope and the accelerometer and the magnetometer to come up with a yaw value. And so I don't know which one of those is actually affecting that, but I've got more stuff I can look at now to go back and try to track that down. So one thing I just need to prove whether or not that heading is usable. And then if it is going to be randomly dropping out, I have to figure out how to get around that.
Yeah, I mean, I don't, that's really odd that it seems to be so variable.
And that's what's so frustrating about it, because it doesn't seem to do the same things 2 times in a row. And it's got to the point I kind of know what it's going to do and what to look for, but it just doesn't seem to be stable enough. I did notice on one of the Ag Open GPS, I think he put up a video on getting the calibration data out of the BNO085, and down in one of the comments the guy said something about, well, I can't get this to work. When I put it on the thing, it seems to change either calibration level or something. And the guy, I can't remember his name, is the guy from Ag Open GPS, the main guy, just simply says, yes, you probably don't want to use this on a moving vehicle, which I think, that's the whole point of having the IMU, is putting on a moving vehicle. And that's where they moved on, I think, to the BNO085. And I haven't found any comments on that, if they find that to work well enough now. I suppose I could go down there. If I had the internet, I could go track this stuff down, or before I go home from the library today, I could try to track that down. But it's so frustrating not having the internet, because all I have is over-the-air television, and there's nothing there to watch. And I can't go to CNN. I say, oh, I'm going to go look up pull-up resistors for teensy. Well, I can't do that because I don't have the internet. So you don't realize it's like when your power goes off in your house and you can't do anything. It's the same kind of concept there.
You're back to the pioneer days, thanks to CenturyLink.
Yeah, just about. So then the other thing was, when I was out trying to drive it around, I got everything fired up. I thought, okay, I'm going to go drive around the yard, and my e-stop kept kicking out. I've been having problems with the remote control, just randomly. It will not turn the e-stop relay on, therefore the main motor and the steering will not do anything. And if I sit there, sometimes it'll kick back in, I can go ahead and drive. And at one time I thought if I was tapping on at either end, I was tapping on, I thought, well, then the relay would kick in. So this time I was sitting there, I got really frustrated because it just would not move at all. And I was pounding on my remote control transmitter. Finally, I just popped the top off, because there's no screws holding on. So I just popped it off and was looking at it, I was poking stuff. And finally, I noticed if I wiggle the little switch on the e-stop switch that's on there, it's one of these industrial ones, so it's got this thing that bolts on, and you got these 2 little switch modules that snap on there. And I noticed if I wiggle one of the little switches, then the relay would kick in and everything start working again. So either I just need to replace that switch, or I need to put physical pull-up resistors on the switch. And it could be that the teensy itself has pull-ups in it, and maybe they're not turned on, or I know if there isn't anything, it says they're weak pull-ups, so they're probably like 50K pull-ups or something. So I might try putting physical, like 100 ohm pull-up resistors on the board, and that might solve the problem. Or if the hole size is the same for this plastic e-stop I've got on there right now, and that metal one that's on the robot, that really, really fancy e-stop switch, which I think has, the switches are integrated right in. I've never had any problems with that switch. If I can, I'll just swap out and put the better switch in. That should solve all my problems. So that's I've been having problems with that my remote control system forever, and sometimes it works and sometimes it doesn't. And I know it's communicating, because if I say push the e-stop switch down, my flashing beacon on the robot changes from orange to red, saying it knows that my e-stop switch is pushed down, but the relay will not engage. And And I did something I thought was clever. That switch has both a normally open contact and normally closed contact. So I read both sides of it, and I said, in order to be active and be safe, the one switch has to be on and the other switch has to be off. So you have to have both switches have to be in the right position to make that work. And if one of them is just a little bit temperamental, then that data coming across means the relay will not engage, but it still understands that I've got the switch on or off. So that's something else I can go look at now that I'm down to that point where I've got stuff to look at and I can track that down.
One day you're a mechanical engineer, the next day you're an electrical engineer.
And the next day I'm beating on stuff. So
Next day you're waiting on CenturyLink.
yeah.
Criminy.
Right hand. I made a list here before I came over, and that's what I wrote down. That's all I can think of. So other than that, it seems to be running pretty well. And it's just it's one of these things where, you got to get the startup procedure right, because if I fire the whole thing up and run my launch file and the IMU is working right, it'll go ahead and fire up and run like it's supposed to. But if I kill the launch file and start it again, now I have to unplug the IMU and plug it back in to get something to reset there. So there's, little steps like that. You got to do it in the right order. And eventually I need to get to the point where any of the sensors, at any point you just say start it up and it will run in whatever condition it's in. So that's one more thing to put on the list to track down.
Are you just, do you have your computer screen there handy? Can you see a screen if I share?
Yes, I can.
I have this is how do I describe it? It's not a hobby. It's an addiction. This is an auction site, and I found a government surplus auction item, and this I was watching this. This is a direction finder. It's probably made in the 50s, but this thing, I didn't bid on it. I was just watching it. I think the auction was actually yesterday. They had two of them. That's what that 2 stands for. And the way this thing, basically it finds north, and it's a manual process, but it finds north. And I thought, plus or minus supposedly, 0.3 degrees. And I was tempted to bid on it. I think I was driving back from Texas, which is why I didn't get to watch the auction. But what happens when it's unsuccessful, which is what this means, is nobody wanted it. In a couple of months, it'll come back up for auction. I think I know that because in a previous auction, there was another similar item that sold for $135. And again, this was a north finding deal. And what's interesting, I find interesting anyway, you might just find completely boring. This particular one, part of the reason I wasn't really going to go buy this thing is because, who knows what protocol it's using and how you would ever tap into it. But they give you these pictures of it, and this is all government, like a government inventory number and an inventory number. The screen is small, so you might not be able to see that, but this was what the government paid for this. Can you see that number?
Yes, I can.
$48,000.
That's why they're called the government.
What triggered my memory on this is it's been demilitarized, which means they can sell it. and that your IMU comment about export compliance, or I forget exactly how they mentioned it to you, but yeah, you don't, I haven't seen these very frequently, and this one didn't sell the first time through because they had a what do they call it when you have an auction and you have a minimum? Well, they had a minimum bid of like $500, and it didn't sell, so somebody paid $135 for it. But anyway, I thought it might be interesting to get the to have something that will tell you if it works, you know, what really north. Or I guess I could go buy, you know, go to the sporting goods store and buy a compass for, you know, $15.
Do you know what technology this uses?
Haven't a clue. Are you going to tell me?
Well, one of the things that they used to use on like airplanes and stuff, you know, if you got a small personal airplane, they'd use radio direction finders. And the thing would actually lock onto AM radio stations around the country. And by figuring out the angle between you and the radio station, they could triangulate and get directions based on that. And if this thing is radio based, then probably you have to have some kind of external antenna, and you might even need a specialized antenna to make it work. The other thing was, when I was looking into the radio direction finders, somebody claimed they're not as accurate as you'd like them to be anyway. So I don't think it was really worth going down that path. But if you wanted to make one, you could get one of these, what do you call them, the software defined radios, and plug it into your computer. And then I don't remember how the antennas work. If you have to have like two antennas, they're 90 degrees apart or something. And then you just scan through your list of radios, and then somehow you could probably make it work with modern stuff without too much difficulty. But somebody was just saying it's not really accurate enough to use in the first place.
Yeah, I mean, I'm reading, I have up on the screen the operating instructions. I mean, and so they're written so some private can operate this thing.
A little schematic down there almost looks like that's like an external thing, and that looks like a three-phase motor. So probably that on the left there's a connector on the side of your box, and this is the motorized thing that was going to turn an antenna or something. So anyway, as you say, not knowing anything about it, and it's going to have weird protocols. You may need external stuff to plug into it to make it work in the first place. Yeah, it would be a nice novelty. You could put it on your living room, your coffee table for people to go, oh, hey, that's pretty cool. But I don't know you'd ever get it to work.
Yeah, it says to supply accurate magnetic detector heading to external equipment, connect test cable, gives a number, to adapter, gives a number, and magnetic detector simulator. So it has an output. Apply.
And the other thing is, on the auction, I think it said calibrator or something. So this is probably not actually the device that detects your north. This is the thing that's going to calibrate it by pretending to be whatever your external antenna is, or whatever it happens to be. So that's another thing you got to be aware of. See, it says direction finder calibrator. So that means it's not actually a direction finder. It's just the thing that's your calibration source to set the thing up, I think, is what they're telling you. Although now you know this kind of stuff exists, now you can go to Google and start searching for, say, military magnetic direction finder or something. You might be able to find where somebody has bought these things, torn them apart, tell you all about how they work, or tell you the principles behind them, and whether this old technology is going to work as good as a $20 module you buy on eBay for modern computers. So that's something else to think about there.
Oh, it's just a it's a compulsion. That's probably it's a compulsion. It's like you watch this and people, you know, it's like all kinds of interesting things. Like things you didn't even know you needed. Like here's a 600 kilowatt generator set. I didn't even know I needed, and it sold for $5,000. You know, and it probably weighs 20,000 pounds, but you know, I could have had it for $5,000, $5,005.
You have to go pick it up though. That's what I notice on a lot of these auctions. You have to go pick it up, and that's,
Yeah,
you know, I'm not going to drive to Texas or Tennessee or
this
New York to pick up something.
Chambersburg, Pennsylvania is where this one was sold. Yeah, but you know, 600 kilowatts. You could power your whole subdivision. But even CenturyLink, you could sell electricity to CenturyLink, Jeff.
Just down below, there's some that had wheels on. So if you buy some with wheels, you might be able to hook onto it and pull it home.
Anyway, now you know why the heck I can't seem to finish my IMU tasks, because I get pulled into a deep, dark rabbit hole.
So speaking of the obsessions, every time I see something on TV where they show a Saturn V rocket taking off, there's something I was watching on, I think it was Nova, and at the end it says, "Draper, we make the parts that make space travel possible." And they've got an animated Saturn V taking off. It keeps coming back to me. How did they make that work? How did they fly to the moon? Did they have mechanical gyroscopes back in those days? So I assume they spin their gyroscope up, and you know, you go through the countdown. They go T minus 20 seconds. They get down to T minus seconds. They say guidance internal. So they switched over to whatever the guidance is. They hit 7 seconds. They do ignition sequence start, and away it goes. And now they're flying for 3 days from the Earth to the moon. And I'm guessing what they do is they're, you know, every so often they pull out their sextant and they find the stars. And they say, okay, here's my exact angle we're heading at, and punch the correction into their gyroscope. But that, I'm sure that's before they had the laser fiber optic gyros. They probably had mechanical gyroscopes spinning inside of that spacecraft to get them from here to the moon. And that's, I keep thinking I should go track that down, because I'm sure somebody's got a big write-up on how all that stuff works, and how it worked, and how they corrected for it, and how well it worked. But they made it to the moon and back multiple times back in the late 60s, early 70s.
So if I Google antique spinning
Well, you can find lots of gyroscopes. There's the Sperry gyroscope, and there's a whole bunch of them that will turn up. But again, are they worth having, or can you just buy, you know, a little MEMS module that's going to be 20 times better these days? So, but it's just interesting. And you know, back in the Apollo program, where they put little dymo markers on their switches actually that was like in the earlier ones, before Apollo, they had the what was it, the Gemini and whatever they called those, and they'd actually take their little dymo marker and put out the thing that says on and off, and they'd stick those right on the panel by the switch. So that's how the early days of rocket travel worked. So I'm sure it's improved much over that now.
Yeah, but it would be interesting just to see what this guy has seemingly got some. You probably aren't in a really good spot to look at this, but I'll put it in the chat anyway. This guy seems to have a bunch of
there's a Sperry gyroscope right there on the list.
Oh, was it?
Yeah, right about halfway down. The Sperry Mark something and a Sperry direction gyro.
1937.
Yeah, that was like back in World War II time frame is when they're using all that stuff. That's how they also had what they called the Norden bomb sight that they put on a plane, and that's how they would do all the calculations to drop a bomb right on Berlin or whatever they're trying to do at the time. So it's really interesting to go back through all this old stuff and look at it. But, you know, we've got now to the point you've got a cell phone that's many times, thousands of times more powerful than the computer that took them to the moon and things like that.
Anyway, I will get back to my, see if I can get my Chip Robotics IMU ROS driver to load up.
And if you get to the point where you want to take your Adafruit board, and I think you had it where it's just dumping out random numbers online. If you want, I can take that and figure out how to publish that in ROS if you want to go down that path. So go ahead and play with this new one right now and see if you can get that running and see what's giving you. But if you want to go back to the other one, I can tell you how to take that string of numbers coming out and publish that as whatever topics you want.
Yes, I want to do that. I think I have. Let's see if I can get it in Windows. The code. I have. I've got the ENU and the human readable compass offset figured out. I just the point that I stopped was, okay, now I'm going to have to put this into a serial line, and then I'm going to have to read that, and then I started to look at your code on how to read it in, but then I need to figure out how to output it to a serial line, and I'm sure it's just not something I've done before. And I'm looking for my code. I don't think it's on my machine.
I just pieced together multiple examples for doing things and stuck them into one program to do what I needed, and eventually I got the numbers out that I needed. So I have been through all the steps, and I can tell you how to publish each separate thing if you need to know that.
Yeah, because that might be faster than me figuring out yet another new piece of equipment, since you had already, do you have to run? Because let me look on my Ubuntu machine here.
No, I'm just relaxing in my car here.
They have strong Wi-Fi if you can.
Yeah, it seemed to be pretty strong. I'm like 20 feet from the side of the building, but this is like the main door in the back, or if I pull over to the side here, there's like a room in the back that's got windows on, and I've parked both places and get a really good signal. They might even have an antenna outside. They may have upgraded it when the COVID hit. They just had a spot so you could come and collect in the parking lot and get it connections, since you can't, because the library was probably closed during that whole thing.
I've got my Ubuntu machine sitting right here next to me, and I haven't. Yeah, as soon as I started to put ROS into this Nano, global variables use 94% of dynamic memory. Low memory, you will have stability problems. And I was just going to publish the quality and the yaw, the human readable compass, and then the Z rotation for the what do you call it? Rotational velocity.
Yeah. But the approach I would take is just figure out whatever numbers you want out, and just have an output to your serial port. Just stack those up as comma separated variables. So it just puts, if you fire up your Arduino serial monitor, it would just be putting out, just a line with all that data on it. And then on the ROS side, you know, either take my example or tell me, and I'll show you how to do that, where you just simply read all that data in. And the first thing I would do, I would publish that as that array, so you can just store that in a bag file, then go back with plot juggler and say, okay, I want to see this value or this value or this value, and just magically plot it on the stuff. And then you can go back and pick and choose and say, okay, I want to know the yaw. So figure out which array entry is the yaw. And on my stuff, it happens to be 0. So you just take that value and scale it any way you want, and then say, have a ROS publisher, and you just say, publish that, and that should work. Now, if you want to make standard messages, because you can make a standard IMU, they have a standard IMU message or standard IMU raw message. So if you want, you can, and it's not hard to do that. You just have to import the proper message type at the top, and then down below say, create one of these messages and stuff the values in and publish that. So you can go either way, depending, because if you're trying to feed it into something else, if you want to feed that into robot localization, it probably wants it in that format, or you can just publish each number separately as separate topics, and just, you can then echo those or put them in a ROS bag, and then pull them up with plot juggler and look at them. So you've got quite a bit of flex. If you're doing this code yourself, you got as much flexibility as you want there to do it.
And you just use a serial print command on the Nano side.
Whatever it takes to get the data out. Yeah. So you just go down their examples and say, oh, here's an example to read, say, the Euler angles. So you just take that example, and it's going to generate a pitch, roll, and a yaw. So whatever they values give you for pitch, roll, and yaw, you just say print that with commas in between those, and then also read up. I don't know. I can't even think. Say you want rotational velocity, figure out from their examples which one gives you rotational velocity. Just pick that up and stick that on that same print line, and so you got another comma separated variable. So just get this line that's about a foot long when you go to look at it. And then when it gets over the other side, the first thing I would do in the node you right there is read that in and then publish that as an array. So you've got all the data in raw format is being published that you can access at any time you want by pulling up that bag file, and then just pick and choose the things you want and publish them, make separate publishers for each one. So just grab one and make it publish it. If that's working, go on to add another one and make it do that. So you can just step through and keep adding stuff to it.
Cool. So I think I'll try to use the example that you put out on Slack and get that to work.
And it could be I've changed it since then. That was just a quick thing to, I think, publish it as an array or something. And I could dig up my new stuff and email it to you if I had internet. But I could find it, and this library is about 4 blocks from my house, so it's not that big a deal. Is that screws in that? I was wondering if that was sealed or if you could get it open.
There are screws.
I'm predicting that's only going to have a BNO085 chip, a voltage regulator chip, and an FTDI chip inside of that box. I doubt if there's a microcontroller in there.
Well.
And you said you tried to use that software on your BNO085 that you have. Well, I think it wants to talk directly to the chip. And so it means you'd have to connect a FTDI adapter directly to your BNO085 module. And then there's something about you have to ground one of the pins to put it in the mode that's going to output that stuff.
I'll take a picture of it with my phone, and so it's more detailed, but
yeah. I can't really make out what's there, but
here, hold on.
I assume one of the big chips is like an FTDI chip. The other big chip is probably the IMU chip. So I think that's probably all that's in there. So it's just a little more slick than getting multiple modules and hooking them together with jumper wires. Are there any jumpers on that board that you could change either dip switches or jumpers where you can change the configuration on it? Because the last time we were going through at the meeting and you went down the line, it says, well, there's like 3 or 4 different output modes that were simple output modes. It could be you've got jumpers on the board, you can switch that. So instead of getting, right now you get pitch, roll, and yaw, and you get the 3 acceleration values. It could be you can change that and get pitch, roll, and yaw, and say rotational velocities or something just by jumpering that differently.
I'm not seeing any. I'm looking at the picture that I just took.
Okay.
And I'm not seeing any.
And it could even be you could send it a command to put it in the different modes too. I only know the way a little bit about how the BNO085 works, and I thought we were looking at the documentation for your chip, and I know it had multiple output modes you could get in this simple UART mode, but I don't know if that's set by configuring jumpers on the chip, or if that you send it a command to put it in those modes. So that's something else you could look at, because you might be able to get your own software to talk to this module you've got in your hand right now. So, just the fact it's packaged nicer than the other stuff that you've got.
Yeah, hold on a second. I'm just trying to find Slack here. Do you have Slack running? I can't tell whether that just sent it to Slack or not.
Yeah, I do have a running. Where did you put it?
Just tried to send a direct message.
Oh, let me go down to my, there, it just showed up.
It did?
Yes, it did.
So I don't get it.
You could post that to say right to the random channel, so anybody that's curious about what's in it, they can go look at it.
See if I can do that.
Yeah, so looking at that chip that says U1, that says 701, that is the IMU, and right next to it is an FTDI chip. So yes, that's all that's in this thing is those two parts. So it's basically, if you connect that, plug that right into a terminal program, just go ahead and plug it in your computer and fire up a terminal program. And probably, let's see, the FTDI has to have baud rate, so you can't just say cat / TTY USB 0, because you got to get the baud rate set. There's probably a clever way to just give it the command to set the baud rate. But if you just fire up, like, say, Minicom or any of the, or on Windows, fire up TerraTerm or whatever you use for Windows to do serial communication, it should just start putting the messages out on the out on your screen. And they're probably going to look just like that stuff that was showing you at the top of that when you're running that program at the top. No, actually, they might be binary messages.
Remember, we looked at the manual, and there were 3 different message formats.
Oh yeah, they're like an AAA in binary. So yeah, there's probably binary messages.
Fantastic memory. And it was called an S format message that they use. And I have not stumbled across the code to turn on the S format message.
And that's where it may take, you may have to change a jumper on the board to make it do that, or you might just be able to send it a command saying, set it to this configuration. So but that gives you something to look at, something to track down and figure out. Because that page you're looking at says, here's the different output formats. It probably says, in order to change these, you have to either send it a configuration command, or it might say you got the S1, S0 jumpers that you have to solder on the board or whatever. And so that module you just had in your hand, they may not give you a way to physically change it there, but the little Adafruit one's got the, it's got the little jumper pads that you can hook to the pins to change those formats. So again, you got lots of different options now with the two different modules, and the one's working. You plug it in and it comes up on your Windows and shows you that it's running. So it's always better to have something you can actually test as opposed to just guessing at it and reading documentation for long periods of time.
Yeah. So, okay, I'm going to get to work on trying to read, use my inexpensive Nano to output ASCII text on the serial port, and then read it into ROS via Python, your Python script running on the Pi. That's what I'm going to do.
And the other thing I noticed, I think it was the Adafruit examples or the Adafruit driver for the BNO085. Under the examples, they'd say, here's an example to read pitch, roll, and yaw. They say, here's another example to read something else. And they didn't seem to show one where it would read all the stuff and output it, you know, so they'd show you each individual one and you got to figure it out. They did have what I said, there's one called read multiple. And I don't know if that was to read two BNO085 sensors or it meant they're reading two different messages and outputting at the same time. So you just have to figure out how you can read up, you know, as many things as you want. And then once you have the values for all those, yeah, you just do a print statement and shove the thing out. And that's really all it comes down to. So it's just up to you to pick and choose what you want to see. And at this point, you can grab a lot more data, you know, generate a lot more data than what you need. And then when you get to the other side on ROS, you can just pick and choose. And the data will already be there for you. So you can just say, okay, I just want to know yaw, and I'm going to publish that. Then come back tomorrow and say, well, I'd also know like to know rotational velocity. So go to your list of input you just created and grab that and publish that. So that makes it a fairly easy way to do that.
Yeah,
fairly flexible.
The guys at SparkFun have done a nice job. They do have you mentioned Adafruit, but I found SparkFun's they have a reading one IMU, multiple messages off the same IMU, which is definitely helpful. Definitely helpful.
Yeah, I would say pick whichever library looks like it's gonna be easiest to use. And if they've got the one that's already outputting multiple messages, you know, just go with that and either take the message that they've got or just use that as an example to add on more messages and just dump the whole. They usually put up a nice formatted message so you can read it on the screen. Just rip out all the formatting and put that all in a single line of comma separated variables. Or you could put a thing in your code and say, if this is defined, then put it out in the human readable format. And if it's not defined, then put it out in the big long string of numbers that you're going to use for your ROS stuff. So that might be another way to do that. So it's just like an if then in your code. You can either say if defined and have something called debug, or you can say if this bit is set, then do this print statement, otherwise do the other print statement. And that way you're not constantly changing back and forth or constantly commenting stuff in and out to do that. I just did that on my IMU because it puts out like, you know, 3 pages of debug messages as the thing starts up. But if I feed that to my ROS driver, it's going to say, oh, those aren't valid numbers. So I just put a thing at the top. I said, if defined debug, or I said, pound define debug. Then down in the code, I said, for every print statement, I said, if define debug, then do this print statement, and then said, pound end if. And that way I can just go change that the line that says pound define debug. If I comment that out, then it puts all the debug statements will show up on the screen. If I uncomment that, or whichever way, I think I said that backwards, but I can either have it so it just dumps out the comma separated variable lines for ROS, or I can go change that and recompile it and download it, and then it puts out the nice formatted block and all the extra messages so I can see what's going on. So it just, in the long run, that just makes it easier if you can quickly change back and forth without having to, you know, do massive changes to your code every time.
I know it sounds simple and easy for you. Do you mind sharing that if you get a chance?
I'll whip up something that says, you know, here's an example of how you do that. Right now, I've hacked on this code so much it makes absolutely no sense at all right now to anybody. So I probably shouldn't just dump that out, because then people are gonna say, well, I'm trying to do it just like you did here. Say, well, you shouldn't be. That's the problem. Yeah, I can go home and I got to get off the other computer and I'll just whip up a little example of how to do that. And then, as I say, the library's only like 4 blocks away. It's a quick drive over here to get an internet connection and then fire stuff off. And then I notice nobody's sending me emails anyway, so it's not worth a lot of effort to come over here several times a day because nobody talks to me anyway.
And how many people are in the library, or have you even been inside?
No, I haven't even been in. There's like 5 cars in the parking lot in the back, and some of those people might actually work here. I see people coming and going. There's a return slot on the side here that they're returning stuff. And then I see a few people do go in. Oh, in fact, this woman's going in right now. So
when you said you're at the library, I thought you were physically in the library, not. No,
I'm just sitting in my car here. And this is just a little tiny public, neighborhood library. And then there's a bigger one. If I go up the road, there's a really big library, but this one is close to my house and it works. So
I
have
think I've never even, I don't know if their Wi-Fi signal is strong enough in our library to be outside anyway. That's a good idea.
I think since they're backed by public or by government money, I think they can put in, big fancy Wi-Fi to make all this stuff work.
Yeah, you know. Okay, man. I'm gonna let you run. Good luck with CenturyLink.
Okay.
Talk to you later.
Okay, bye.